These notes go with section 13.2 in your book, and this section is all about angles that are formed when lines cross and parallel lines. To start off, we need some vocabulary, and I think that this vocabulary is easiest explained in pictures. Let's start here with the word complementary angles. What this means is that if we have two angles that when added together form a 90-degree angle, those two are said to be complementary. For example, we have one angle here, shown in orange, and a second angle here, shown in purple. Those two angles, when you put them together, add up to 90 degrees. So complementary angles add to 90 degrees. Supplementary angles are angles that when we add them together add up to 180 degrees. So in this case, if we have two angles, again I'll show one of them as an angle in orange there. In this case it's a large angle, an obtuse angle, and here we have an acute angle, a smaller angle, and together these add up to 180 degrees. When we add them together, they make a straight line. So these are lines that add to 180 degrees. Vertical angles are formed when two lines cross. So for example, if I take this line here and this line here, and I cross those two, we would say that these angles that are opposite from each other, those are vertical angles. So they're angles that are opposite from each other when two lines cross. Another example of vertical angles might be if I have two lines that cross like this. These would be vertical angles because these are the angles that are opposite from each other when the lines cross. Now you notice that anytime two lines cross, we actually have two pairs of vertical angles. So in the first picture, the two orange angles are vertical angles, and the two purple angles are vertical angles. The same is true in the second picture. The two purple angles are vertical angles, and the two orange angles are vertical angles. So those are just some vocabulary terms as we talk about angles. Now we're going to talk about a transversal. The easiest way to think of a transversal is that it is a line that crosses two other lines. So for example, if I have two lines shown here in black, I can draw in a transversal in orange. It's simply a line that crosses both of them. So this orange line would be the transversal. Corresponding angles are the angles that match up when we have a transversal. And again, I think this is easiest explained with a picture. So let me draw two lines and a transversal crossing them. Let's look at a couple of the angles within this. There's a lot of angles that are formed here. This angle, this angle, this angle, this angle, and then we have four more angles down here. Let's focus on the right side of the transversal first. There's nothing magical about the right side. I'm just picking that one kind of at random. We'll look at angles that are formed on the right side of the transversal above the original lines. So here's one angle. It's to the right of the transversal and it's above the original line. Here's the corresponding angle on the other line. It's to the right of the transversal and it's above the line. We can identify lots of different corresponding angles in this. For example, suppose we focus on the left of the transversal. We're looking for an angle that's to the left of the transversal and below the original line. Here, and a line that's to the left of the transversal and below the original line. So we would say that these two angles shown in purple here are corresponding angles. And the two angles shown in green here are corresponding angles. The next vocabulary term is alternate interior angles. So alternate means something's going to be different between the two of them. Interior means they're going to be inside something. So let's draw our two lines here. And let's draw for ourselves a transversal. I'm just going to draw my transversal at a slightly different angle this time. All right. Alternate in this case means that we're looking for angles that are on opposite sides of the transversal. So if one of the angles is on the right, the other one's going to be on the left. So that's what the alternate part means. The interior means we're looking for angles that lie between these two black lines. So as an example, here's one interior angle. It's an angle that's between the two black lines. I'm looking for an alternate interior angle. That means an angle that's on the other side of the transversal that's also in between the two black lines. The only one I can see is that angle there. So these two, shown in green, are alternate interior angles. There's another pair of alternate interior angles here, and I'll show them as purple. Here's one. And then down here is another. Notice the two angles shown in purple here are on opposite sides. They're on alternate sides of the transversal, and they're both inside the black lines. You can probably guess then what alternate exterior angles look like. Again, I'm going to draw my two original lines. Notice that for this section, these two original black lines don't have to be parallel. So I'm showing them as sometimes parallel and sometimes not. And I'll draw myself a transversal here in orange. Alternate still means that we're looking for angles that are on the outside, on opposite sides of the orange transversal. Exterior means that we're looking for angles that are outside of, that are not between the black lines. So here's one alternate angle. It's an angle outside the two black lines. The alternate exterior angle is on the alternate side of the transversal, and it's also outside the two black lines. So these two green angles are alternate exterior angles. And once again, there's another set of alternate exterior angles that I'll show in purple. Here's one, here's the other. Let's work together through example 1 and identifying angles. In this diagram, it says that line T is a transversal. Here's the letter T, so this is line T. This is our transversal. Tell whether the angles that are specified in each of these three pairs are corresponding angles, alternate interior, or alternate exterior angles. So first we're asking about angle 1 and angle 5. Angle 1 is here, and angle 5 is here. These two angles occupy corresponding positions. In this case, they're both above the transversal and to the left of the original lines. So these two would be corresponding angles. Next, we'll look at line 2 and line 7. Sorry, angle 2 and angle 7. Angle 2 is here, and angle 7 is here. I notice that they both lie inside the original two lines, so I'm thinking that they're alternate interior angles. Do they meet that alternate criteria? Well, they're on opposite sides of the transversal. They're on alternate sides of that transversal, so they do indeed meet the criteria for alternate interior. Last, we're looking at angle 3 and angle 6. Angle 3 is here, and angle 6 is here. These are both exterior angles. They're both outside of the two original lines, and they're on alternate or opposite sides of the transversal. So these are alternate exterior angles. Please pause this video for a moment while you write down any questions that you have about this vocabulary and what we've done so far in the white space at the bottom of your page. When you're ready, you can move on to the next page. Next, I'd like you to try the problems in the checkpoint on your own. Notice that for these questions, it's asking you to look back to example 1. So you're going to need to flip the page back and look at angles 4 and 5 on the previous page, and angles 1 and 8 on the previous page, and angles 4 and 8 on the previous page. When you're done with your notes, please do check in with me to make sure that you got all 3 of these right. Once you've done those, next you're going to pause this video and you're going to go into Moodle to watch something that's labeled Khan Academy video about transversals and parallel lines. It's a little video of somebody else explaining transversals and parallel lines that's helpful to watch before you take your notes. In this next section, we're going to investigate what happens when a transversal, line T, in this case here, intersects 2 lines that are parallel. Remember, parallel lines are lines that continue on forever and ever and never cross. In this case, line M on top and line N on the bottom are parallel. The way we show this in a diagram is that we have these little arrows, the same number of arrows, so a single arrow on each of the 2 lines indicates that they're parallel. When we have a transversal that intersects or crosses 2 parallel lines, there are some interesting things that happen with the angles. So let's take a look at the angles one at a time. Angle 1 here has the same measure. That's what M angle 1 means, is the measure of angle 1. If we measured this with a protractor, it would have the same measure as its corresponding angle, angle 5. So the measure of angle 1 is the same as the measure of angle 5. Corresponding angles have the same measure when the 2 lines that the transversal is crossing are parallel. This is true no matter which corresponding lines we're looking at. So angle 2 has the same measure as angle 6, because those 2 are corresponding lines. And angle 3 has the same measure as angle 7, because those are corresponding angles. And finally, we see that angle 4 has the same measure as angle 8, because those are corresponding angles. We'll also notice that when we have a transversal crossing parallel lines, the alternate interior angles are going to have the same measure. So let's take a look at this. Angle 3 has the same measure, so that's here, angle 3, has the same measure as its alternate interior angle, angle 6. So the measure of angle 3 and the measure of angle 6 are the same. Likewise, the measure of angle 4 is the same as the measure of angle 5. So this angle here, angle 4, and this angle here, angle 5. They're opposite or alternate interior angles, and they have the same measure. If we used a protractor to find the number of degrees in that angle, it would be the same. Lastly, if we look at the alternate exterior angles, so let's compare angle 1 up here, the measure of angle 1, and the measure of angle 8 are going to be the same, because they are alternate exterior angles. They're on alternate sides of the transversal, and they're outside of the 2 parallel lines. And angle 2 up here is going to have the same measure as angle 7, because those are also alternate exterior angles. So let's try this with some actual numbers in place of the angle measures. It says that in this diagram, the transversal T intersects the parallel lines M and N. And if the measure of angle 1 is 100 degrees, so I'm going to write that in here, 100 degrees. Find the measures of the other numbered angles. Well, it says the measure of angle 5 is the first one we're looking for. So we're comparing angle 1 to angle 5. I notice that these two are corresponding angles. And we learned in the previous section that when a transversal crosses parallel lines, corresponding angles have the same measure. So we would say that the measure of angle 5 is also 100 degrees because angle 1 and angle 5 are corresponding angles. We would say that the measure of angle 4, so this is also 100 degrees. We would say that the measure of angle 4, well, let's see, angle 4 and 5 are alternate interior angles, so they have the same measure. So the measure of angle 4 is also 100 degrees because angle 4 and angle 5 are alternate interior angles. So I can write in 100 degrees on angle 4. The measure of angle 8, let's see, angle 1 and angle 8, these two are alternate exterior angles. They have the same measure. So the measure of angle 8 is also 100 degrees because angles 1 and 8 are alternate exterior angles. So I can label this one as 100 degrees. The measure of angle 2. All right, angle 2, let's see. Well, its alternate exterior angle is 7, and I don't know the measure of angle 7 yet. Its corresponding angle is angle 6, and I don't know the measure of angle 6 yet. But here's what I do know. When I add angle 1 and angle 2 together, so the measure of angle 1 plus the measure of angle 2, those have to add up to 180 degrees because those two are supplementary angles. When I add together angle 1 and angle 2, I get a straight line that's 180 degrees. If this is 100, then this one must be 80 for them to add together to 180. So the measure of angle 2 is 80 degrees because angle 1 and angle 2 are supplementary angles. Now we have some information we can use to figure out the remaining angles. Angle 2 and angle 6 are corresponding angles. They have the same measure, so this must be 80 degrees because they're corresponding. The measure of angle 3, well, angle 3 and angle 8 are, angle 3 and angle 6. 3 and 6 are alternate interior angles. They have the same measure. And angle 7, the one angle we don't know yet, angle 2 and angle 7 are alternate exterior angles, so they must both have a measure of 80 degrees because they're alternate exterior. So we started out knowing only one of the 8 angles here, but we were able to very quickly label the measures of all the other angles here using just a little bit of information about what happens when a transversal crosses parallel lines. You're going to pause this presentation and do the checkpoint number 4. What I would suggest that you do is redraw the diagram above. So let's make ourselves 2 parallel lines and a transversal that crosses them. Here. And we're going to label our angles 1, 2, 3, 4, 5, 6, 7, 8. All we've done is recreated the drawing that's above. And it tells us if the measure of angle 2 were 85 degrees, so this is a different problem than what we did above. If the measure of angle 2 were 85 degrees, what would the measure of all the other angles be? So in your answer here, you're going to have to write measure of angle 1 equals, and then a blank. Measure of angle 3 equals, and then a blank. Measure of angle 4 equals, and then a blank, and on for the rest of them. Please pause and work through this, and then we'll finish up the very last section in this before we move on. Okay, you should have finished the checkpoint example. Come check in with me when you're done so that I can tell you whether you got it right or wrong. The very last section of these notes is example 3, and it says finding the value of a variable. Now the problem says find the value of x, so what number do I have to replace x with, that makes the lines m and n parallel. Notice that in this diagram there's nothing that shows me that m and n are parallel to begin with. They look kind of parallel-ish, but I can't tell that just by looking. But here's what I know. If a transversal crosses two lines, if it intersects two lines, and the corresponding angles have the same measure, if I can make it so that the corresponding angles are the same size, then it means those lines must be parallel. So if I can find a value for x that makes this angle and this angle have the same measure, be the same number of degrees, then that will make these two lines, m and n, be parallel. So here's what it says for the solution. The labeled angles in the diagram are corresponding angles. They're angles that go with each other, and that's true whether the lines are parallel or not. Here's what's special about this. Lines m and n are only parallel when the measures of those corresponding angles are equal. So what we have to do is make this angle, whose measure is 3x plus 15, equal to this angle, whose measure is 42 degrees. This looks like a simple algebraic expression with one variable, much like the work we did at the beginning of the year. To solve this for x, to find out what value of x makes this equation balance, the first thing we have to do is to subtract 15 from each side. When I do that, when I subtract 15 from each side, on the left-hand side, all that's left there is 3x, and on the right-hand side, 42 minus 15 is 27. Now, I'm going to divide each side by 3. 3 over 3 is just 1, so all I'm left with on this side is 1x, or plain old x, and 27 over 3 is 9. So when x is 9, when I replace this number here with 9, these two angles have the same measure. They're both 42 degrees. When these corresponding angles have the same measure, these two lines are parallel. This is the end of the notes for section 13.2. Please feel free to write questions in the margins or below, and come see me before you start work on the next page.